solution of a system of linear equations, right? So in this topic, right, so what we are going to learn is we are trying to solve a set of linear equations. For example, if you take a simple example, 2x plus 3y equal to 4, and let us say 3x plus 2y equal to 7. So these two are actually a set of equations which will represent two different equations. Now here, for solving this equation, there are actually different kinds of methods actually we are going to adapt it. Now here, in our matrix method, what we are trying to do it here it is, this can be written as 2, 3, 3, 2. This is x and this is y. And this way, you can write this as 4, 7. So this is the form of the matrix. So in this particular format, actually, we will be trying to solve by taking the inverse and then multiplying here. You are going to get the value of x and y. So this is one method. But coming to the numerical methods, what we are going to adapt, right? So there are three different popular methods that are available for us. One is, the first method is Gauss elimination method. The second one is Gauss-Jordan method. The third one is Gauss-Seidel method. So these are the three different methods actually that we are going to adapt to solve any particular equation. Now here it is. So this is the matrix format. In this matrix format, or actually normally what we are trying to solve here it is, so this is 2x plus 3y equal to 4, and then here 3x plus 2y equal to 7. Now I wanted to eliminate this value so that I can make the matrix form simpler. For that, what I will do is, I will try to multiply 3 here and I will try to multiply 2 here, and then I will form a different equation, that is 3 into 2 is 6x plus 9y equal to 12, and if I multiply this here, this is 6x and then plus 4y equal to 14. Then actually I will subtract it. So by subtracting here, what I do is, I am cancelling this equation, which essentially means that I am avoiding this equation and then trying to get the value of y directly by taking, so this is 5y is equal to minus 2 and y is equal to minus 2 by 5. This is how actually you are going to get it. Now the same thing you can get it in a different method, that is 2, 3 and then 4 I will put it here, and here 3, 2 and 7 I will put it here. This I will form as a matrix. And this matrix, if I do, so if I wanted to make this as 0, what I need to do is, this is called as the row R1 and this is R2, row 1 and row 2. So in case of this Gauss elimination method, what we will do is, we will try to form an upper triangle matrix like this, where I can make all the lower triangle values 0. For that, actually, there is a standard method which you can adapt it. So that method is, if I wanted to make this value is 0, what I will do is, R2 can be written as 3 times of R1 minus 2 times of R3. So if I do this operation, then I can replace that value, sorry, this is R1. 3 times of R1 minus 2 times of R2. So if I make this operation and replace the row as R2, then actually I can get the value here as 0. So for that, what I will do is, so 2, 3, 4, I will keep it as it is, and then for the second one, 3 times of R1 is 6 and 2 times of R2 is 6 again, this will be 0, and then 3 times of R1 is 9 minus 2 times of R2 is 4, this is going to be 5, and again here also 3 times of R1 is 3 4s are 12 and 2 7s are 14, this is minus 2, and then this is how I will form the matrix. Then this equation can be rewritten by eliminating this value. This eliminated value, now these two equations I can write again in the normal equation format rather than this matrix format, as 2x plus 3y equal to 4 is one equation, and another equation is 0 into x plus 5 times of y is equal to minus 2, which essentially means that y I can calculate as minus 2 by 3, which I have got in the normal procedure as well. So if you are able to successfully eliminate this value to 0, then I can get the same answer as that of the normal solution of the equation. Now once I get the value of y, what I will do, I will substitute back into the original equation so that I can get the value of x. So for that, 2x plus 3y equal to minus 4 and y is equal to minus 2 by 3, 2x is equal to minus 4, 2x equal to 4 minus is 3y. So 3y is minus 2 by 3. So if I replace here, this is 4 plus 2. This is 2x, or x is equal to 3. So this is the answer. Got it? Sorry, this is 2 by 5. No. 2 by 5. So this is going to be plus 6 by 5. So this is the answer. So 13 by 5. Yeah. So this is the answer. Got it? So like this, actually you will be able to calculate the value by making this as 0. The same procedure whatever we have adapted here in case of two-dimensional. So we are going to adapt the same procedure even for the 3D as well. So if there are n different simultaneous equations what we wanted to solve, then the same methodology can be adopted as long as these equations are the linear equations. As I said earlier, so this linear equation will contain only the power of x and the power of y as 1. There won't be any multiplication, or there won't be any non-linear terms like e power x or x square or like that. So these are the set of equations which we call as the linear equations. So there is a separate topic called linear algebra which essentially deals with this matrix operations. So any set of linear equations can be brought into the matrix format, and you will be able to solve the matrix format by adopting the methods: Gauss elimination method, Gauss-Jordan method, and Gauss-Seidel method. Got it? So this method, whatever we have explained here, this is Gauss elimination method. So by eliminating the lower triangle elements and keeping the upper triangle elements, you will be able to calculate the last value first and substitute the value to the previous row and get the next value, and substitute these two values to the next row and then get the value of the third one. Like this, actually from the bottom to top, you will be able to substitute the values and calculate the unknown values there. So this method is called the Gauss elimination method. Now the same thing actually I will try to explain with one problem for Gauss-Seidel method with 3 different dimensions equations. Got it? Yeah, you can note down this. Apply Gauss elimination method to solve the following set of equations. So this set of equations are x plus y plus z is equal to 9, and the second one is 2x minus 3y plus 4z equal to 13, 2x minus 3y plus 4z equal to 13. And the next one is 3x plus 4y plus 5z equal to 40. So this is the equation. Now this equation, by forming the augment matrix, this is 1, 1, 1 and 9. And the next one, 2 minus 3 plus 4 and plus 13. And the next one, 3, 4, 5 and 40. So this is the matrix. Now actually on this I wanted to apply Gauss elimination method. Gauss elimination method, which essentially means that with the help of this first row first element, you will be making the second element, so second row first element and third row first element as zeros with the help of this number. And so this is the first step. In the second step, these two will become 0, and then there will be a value here, and there will be a value here, and there will be a value here as well. Now here, with the help of this value, you will try to make the next value as 0. And so that all these three values will become 0. And then with the help of this upper triangle matrix, we will do back substitution to get the values of the unknowns. So this is the method what we are going to adapt. Now, first operation what I will do is, so this one, I will take 2 times of R1 minus R2. I take this as R2. 2 times of R1 minus R2. So this is 2 minus, so first I will keep R1 as it is, 1, 1, 1, 9. And this one, 2 times of R1 is 2 minus 2, 0. And 2 minus of minus 3 is plus 5. And then 2 minus 4 is minus 2. And 2 times of 9 is 18 minus 13 is 5. And similarly, for R3, what I will do is, I will take 3 times of R1 minus R3. So 3 times of R1 is 3 minus 3 is 0. And 3 minus 4 is minus 1, and 3 minus 5 is minus 2, and 27 minus 40 is minus 13. So in one equation, if there is a negative sign for all, you can cancel it by multiplying one operation, that is minus R3 equal to R3. So this operation, if you make it, this will become 0, this will become plus, all are actually plus now. So that actually your calculations are easy rather than multiplying with the negative numbers. So this is for the entire equation, not for a single element. So this way, I have made these two elements as 0 with the help of the first one. And then here actually, I don't have 0 at this location. For that, I can make use of this row, this element, and I can make this value as 0. For that, what I will do is, in the next operation, I will take R1 as it is R1, and R2 as it is R2, and R3 what I will do is, R3 value, R2 minus of 5 times R3. So that actually I can make this value 0. So R2 minus 5 times of this. So first row is 1, 1, 1, 9. And the second row is 0, 5, minus 2, 5. And the third row is 0. So actually when you are multiplying here, this being 0, it won't affect this value. So this will still be 0 for us, even whatever may be the value you multiply here. So R2 minus 5 times of R3 will not change this value. So here 5 minus of 5, this is going to be 0. And 5 times of, so this is minus 2, minus 5 times of R3 is 10. So minus 12. And then 5 minus 5 times of 13 is 65. 5 minus 65 is minus 60. So this actually you can again multiply with the negative sign, and then actually you can still keep this value. Now here 12 times of 6, so 12 and 60 is there. Now you can, if there is a common table that you can cancel, then you can still cancel it. That means 60 by 12 is 5. So then actually you can keep 1 here and you can keep next value as 5. So this is 1, 1, 1 and 9, and the next one is 0, 1, minus 2 by 5 and 1, and this value is 0, 0, 1, 5. So this is R1 as it is, and R2 by 5 and R3 by 12. So these are the operations actually I have done for further simplification here. Now what I have got is this equation. So if I write the last equation, 0 into x plus 0 into y plus z into 1 is equal to 5, which essentially means that z is equal to 5. And if you substitute the value here, this is x into 0 plus y into 1 minus 2 by 5 times of z is equal to 1. Now z value, actually we got to know that this is going to be 5. So y minus 2 by 5 times of 5 is equal to 1. So 5 will cancel and y equal to 2. We have got z is equal to 5 and y is equal to 2. Then you can bring back to the original equation, x plus y plus z is equal to 9, and x plus y is 2 and z is 5. This is going to be 9. So it implies x equal to 2. So these are the solutions. Got it? So here actually we will be virtually forming a matrix in our computers in programming. So this is kind of a two-dimensional array for us. So in the two-dimensional array, actually we will try to follow this procedure and then actually try to subsequently make the zeros and then slowly substitute back, and then actually you can bring it to the final solutions. Here actually, if you notice, in the forward direction actually we are adapting the normal iterative process, but in the backward method actually you are still using the analytical method for the backward substitution. So forward process is easy, but backward process actually you need to solve the substitute the values and then calculate the values. This is a little clumsy. For that actually Jordan has actually suggested one method, that is Gauss-Jordan method. Why can you make as only the lower triangle as 0? But if you are able to make this as a diagonal matrix by eliminating these values also, then actually that is what we call as the Gauss-Jordan method, where the matrix is a diagonal matrix. Then you can straight away, this value divided by this value will give the z value, and this value divided by this value will give the y value, and this value divided by this value will give the x value. So directly in one shot, in the two steps actually you are making this lower triangle matrix. In again two steps you are making this as the diagonal matrix by making upper triangle as 0, and then actually you will be left with only the diagonal elements and you will be straight away calculate the unknown values. That is Gauss-Jordan method. So this is a little improvement from the Gauss elimination method. That's all. Got it? Okay, you can note down this. Yeah, so even if you don't do this operation also, still you will get the same answer, right? So it is up to you whether you wanted to do or not. For simplicity purpose, I have done this. Even if you don't do, but still you are going to get the same answers. Now, coming to Gauss-Jordan method, we are trying to make as the diagonal matrix rather than the upper triangle matrix. So for that actually, we will proceed from the same process. So, but a little two more steps further. So this is Gauss-Jordan method. So now actually, Gauss-Jordan method. So for Gauss-Jordan method, form the diagonal matrix. And calculate the values rather than back substitution. So in this actually we came to this position after doing two different matrix operations. So this matrix actually, I will further simplify this as 1, 1, 1 and 9, and then so this actually I will keep it as it is 5 minus 2, because actually if I have the fractions actually the multiplication will be little clumsy. So I will keep as it is 5, and then this is 0 and this is 0 and this is 0. If I divide with 12, then this is going to be 1 and this is going to be 5. So this is the matrix I have got after two different matrix operations. Now here actually if I wanted to make this as the diagonal elements or the diagonal matrix, then what I need to do is, so here actually I have to make use of this number to make this value as 0. So for that actually what I will do is R2 equal to 2 times of R3 plus R2. So 2 times of R3, if I multiply any number, so these two are actually anyway 0, hence actually there won't be extra additions for this when you are adding to this. So 0 times multiplied by 2 is going to be 0. 0 if you add to this row, it won't make any change to this number. But here also 0 times of 2 and getting multiplied and then actually added to this number, then it won't make any change to this number because you are adding anyway 0. But here it will definitely make a change, and the intention is you wanted to make this as 0. For that actually you can make use of this number to make this value as 0 and this value as 0 without disturbing this diagonal, without disturbing this bottom triangle. Got it? Now here actually if I make 2 times of R3 plus R2, so this I made as R2, so this is 0, 0, 1 and 5. So this is again 0, and this is 2 times of R3 is 0 and 5 as it is. 2 plus minus 2 is going to be 0, and 2 times of 5 is 10, 10 plus 5 is 15. And then if I wanted to make this as 0, what I can do is R1 equal to R3 minus R1. So if I make this operation, this is going to be 0. So for that actually R3 is anyway 0, 0 minus 1 is 0, sorry 0 minus 1 is minus 1, and 0 minus 1 is again minus 1, and 1 minus 1 is 0, and 5 minus 9 is minus 4. So being the same sign, you can cancel at all the locations. So this is one operation where you have made this number as 0. Now you can make use of this number to make this value as 0. For that actually what I will do is so in the next operation R1 equal to R2 minus 5 times of R1. So R2 minus of 5 times of R1. So this is going to be minus 5 times of R1 is minus 5, and this is 0, and this is 0, and this is R2 is 15, minus 5 times of R1 is 20, 15 minus 20 is minus 5, and this value keep it as it is 0, and then 5 and 0, 15. And here 0, 0, 1 and 5. Now if you cancel here fifth table, this is going to be 1, 0, 0, minus 1, so 1, 0, 1, 0, 3, 0, 0, 1 and 5. I think it's not tallying with the answer, right? 1, 3, 5. Yeah, this is correct. In the previous one, okay, anyway, so this answer is correct. So I will check actually where the mistake in the previous one. So this answer is correct. So 1, 3, 5. Yeah. So this is from this actually z is equal to 5 and y is equal to 3 and x is equal to 1. The previous one, I think x and y came out to be 2 and 2. So this actually we are going to correct it now. Yeah. Done. So is this understood process? So only thing is you are trying to make a diagonal matrix here rather than the upper triangle matrix, right? So for that actually you are following the steps. So in the previous one where we started, right? So this is coming out to be 1, 1, 1, 9 and 0, 5, minus 2 and 5 and 0, 0, 1 and 5. So here actually from this equation you can make again z is equal to 5, and the back substitution if you take it 5y minus 2z equal to 5. So from this if you multiply this z as 5y minus 2 into 5 equal to 5, 5y equal to 15 and y is equal to 3. So if y is equal to 3 then x is going to be 1. Yeah. Maybe you can check it. So this is the answer. So this is actually through Gauss elimination method. If you substitute it, you are going to arrive at the same answer. Got it? Yeah. Last answer is not correct. This is correct. So even the Gauss elimination method also, it is the same answer, and Gauss Jordan method also, this is the same answer. Got it? So this is how actually you will be able to solve this Gauss Jordan method or Gauss elimination method to solve any set of simultaneous equations. Got it? Note down one more. You try on your own. So by noting down this. So these equations are 3x plus 2y plus 7z. is equal to 4. And the next one, 2x plus 3y plus z is equal to 5. 2x plus 3y plus z equal to 5. The next one, 3x plus 4y plus z equal to 7. So both Gauss elimination and Gauss Jordan method. Can you try to solve this on your own? So let me solve it. See this matrix you can form as 3, 2, 7, 4, 2, 3, 1, 5. 3, 4, 1, 7. Now if you want to eliminate this, so you can directly subtract from R1 to R3. And then here actually you have to multiply this here and multiply this here and subtract it. So R1 will be R1 as it is, and R2 equal to, R2 you can write as 2 times of R1 minus 3 times of R2. And R3 you can straight away write as R1 minus R3. So if you do this operation, R1 is as it is 3, 2, 7, 4, and R2 is, so 2 times of this and 3 times of this. So 6 minus 6 is going to be 0, and 4 minus 9 is minus 5, and 7 minus 3 is plus 4, and 4 minus 15 is 8 minus 15. 8 minus 15 is minus 7. And then here, this is going to be straight away 0, and 2 minus 4 is minus 2, and 7 minus 1 is 6, and 4 minus 7 is minus 3. So this is after the first operation, you have made two values as 0. And then for the second one, if you want to make this as 0, then what I will do is, so maybe actually I will cancel minus on either sides. Okay, so for this I will multiply with 2 and multiply with 5 here, and then I will try to subtract the last one. So R1 is as it is R1, and R2 is as it is R2. And for R3 actually what you can do is 2 times of R2 minus 5 times of R3. So this operation if you do it, then actually this is 3, 2, 7, 4, and 0, 5, minus 4, and 7, and this is 0, and here 2 times of R2, this is 10, minus 5 times of R3 is, this is again 10, this is going to be 0, and 2 times of minus 4 is minus 8, minus 30. So minus of minus is plus 30, minus 8. So 30 minus 8 is 22. And then 2 times of 7 is 14. 14 minus 15 is minus 1. So this is the next one. So here actually, if Gauss elimination method is adopted, then from here actually you can substitute z is equal to minus 1 by 22, and So 5y minus 4z equal to 7. So 5y equal to 7 plus 4 times of minus 1 by 22. So this is 2 by 11. 7 minus 2 by 11. 77 minus 2, this is 75 by 11. 75 by 11 is 5y. So y is equal to 75 by 5. 15 by 11. And similarly, 3x plus 2y plus 7z equal to 4. Now we can substitute here and we can calculate the value of x. So this is 3x equal to 4 minus 2 times of 15 by 7 by 11 minus 7 times of z value is minus 1 by 22. Three x equal to 4 minus 60 by 22 minus of minus is plus 7 by 22. 88 minus 60 plus 7 divided by 22. So this is 88 minus 60 is 28. 28 plus 7 is 35 by 22. I think this should be the answer. Okay, so let me check it. I think so the answer is not matching with the textbook. 3x plus 2y plus 7z equal to 4. I think so this is where the mistake is. Yeah. So this is 2 times of R1 minus 3 times of R2. So 2 times of R1 is 14 minus 3 times of this one. 1 is 3. So 14 minus 3. So 14 minus 3 is going to be 11, I think. Yeah. So you can check it. So this is actually 11. So then actually 8 minus 15 is 7. Yeah. So this is going to be minus 11. Then from there actually all the calculations will go for a task. Yeah, so this is correct, I think. Z is equal to minus 1 by 2 is correct. So from here actually, so Z value is coming out to minus 1 by 8. Here 5y minus 11 Z is equal to 7. And this is 5y plus 11 by 8 equal to 7. And y is equal to 7 minus 11 by 8. This is 5 times. 24 by 8. So y is equal to 9 by 8. 3x plus 2y plus 7z is equal to 4. From this, 3x plus 2 times of 9 by 8 plus 7 times of minus 1 by 8 equal to 7. You can calculate this x value. It should be 9 by 8 is correct, and this is 7 by 8. Yeah. So this is the answer. Akhil, you can check it. So z and y are correct, and x should be equal to 7 by 8. Yeah. Fine. So this way actually you can use Gauss elimination method to find out the unknown values. Now the same thing actually we can extend for the Gauss-Jordan method. So for Gauss-Jordan method, what you have to do is we have to make use of this one to make these two values as 0. For that actually what you can do is R3 will be as it is, and R2 what you can do is, so you can multiply this value here and this value here and add it together so that actually you can keep the value as 0. So that is R2 equal to 8 times of R2 plus 11 times of R3. So I am using plus here rather than minus. So 8 times of R2 is here actually is coming out to be minus 88, and 11 times of R3 is going to be 8 plus 88. So you can make as 0. And similarly R1 also you can make as 7 times of R3 and 8 times of R1. So this way, so this is going to be, first I'll write the last one 0, 0, 8 minus 1, and then 8 times of R2 plus 11 times of R3. So here this is going to be 0, and 8 times of R2 is 40, and this is 0, and this is 8 times of R2 is 56, and plus 11 times of minus 1 is minus 11. 56 minus 11 is 45. And the next one 8 times of R1 minus 7 times of R3. This is 24. This is 16. and 8 times of R1 is 56 minus 7 times of R3 is 0. So this is 32 plus 7, this is 39. And then you can calculate fifth table here, and this is 24, 16, 0, 39, 0. Now if you want to make this as 0, multiply with 2 here and then subtract it. R1 equal to 2 times of R2 minus R1. So this operation, if you make it, then actually this is going to be 2 times of R2 minus R1. So this is minus 24, and 2 times of R2 is 16. Minus 16 is going to be 0. 0 minus 0. This is 0. And 2 times of R2 is 18, 39. So 18 minus 39. Minus 21. 0, 8, 0, 9. 0, 0, 8, minus 1. So these are the values. So which is a diagonal matrix now. Now from this actually 8z equal to minus 1, it implies z is equal to minus 1 by 8. And similarly 8y is equal to plus 9. It implies z is equal to 9 by 8. Similarly minus 24, x is equal to minus 21. It implies x is equal to 21 by 24. So 7 3s to 8 3s. 7 8. Got it? So this is how actually we can calculate the unknown values with the help of either maybe Gauss elimination method or Gauss-Jordan method. So in the next method, right? So this is actually, if you notice, this is as if like it is the analytical method itself. So you are trying to interpret this analytical method with the help of computers for whatever may be the number of equations you wanted to solve it. Here actually we solved for a 3D equations. 3D equations we mean 3 different simultaneous equations which has a solution. But if you notice the limitation of this numerical methods, as I said here, right? So we are not assuring whether the system of equations are having a unique solution or infinite solutions or no solution. So that is the limitation here. So first of all, actually, when we are trying to adapt any particular solution, first of all, we have to assure whether the solution exists or not. If exists, then actually we can calculate. If you notice all the problems, whatever we solved, right? So are actually consistent, which essentially means that the solution is only one solution and unique solution. So that is why actually we were able to find it out. So that is actually the order of the matrix or the order of the augmented matrix and the order of the original matrix or the coefficient matrix is same. Then only actually you can get this kind of solution. But if the order of the augmented matrix and order of the coefficient matrix doesn't match, then actually the question of the existence of the solution that comes into picture, right? That we are not assuring it here. That you are going to learn as part of linear algebra. Got it? So that is the limitation. So assuming that this is having a unique solution, we are trying to solve it here. Now, this is actually a procedural or analytical method what we have adapted either in Gauss elimination or Gauss-Jordan method. But there is one more method called Gauss-Seidel method, which is an iterative method. So iterative method, which essentially means that, so here the same solutions we can even find out with the help of the iterative method without doing this matrix operation or the analytical operations. By randomly assuming any particular solution, we still be able to solve. So if you substitute any particular value for this equation, the method what we are going to adapt here it is, here actually we express this value as x is equal to 1 by 3 times of 4 minus 2y minus 7z. So this is one equation. And then this one, what I will do is, I will express for y is equal to 1 by 3 times of 5 minus 2x minus z. So this is equation number 2. In the next equation, z I will express as 7 minus 3x minus 4y. This is equation number 3. So out of all the 3 available equations, what I will do is, I will express as one as x equal to, another is y equal to, another is z equal to. Now you start iterating by calculating these values by assuming a random initial solution. So let the assumed solution, or let the initial solution be 1, 1, 1. So this is the initial solution. This 1, 1, 1 value, I will put it in the first equation. So if I put it in the first equation, I am going to get the value of x1. So this equation is nothing but x0, y0, z0. And then x1 value I will be able to calculate with the help of this equation, where I can keep the values of y and z as the initial solution as 1, 1. So this equation x1, which is the new solution or the new approximation of x, is going to be 1 by 3 times of 4 minus 2 minus 7. So this is 4 minus 2 minus 7 is 4 minus 9, and this is going to be minus 5 by 3. And then when I try to calculate the value of y1, I have got a better approximation than the initial solution, which was 1. Now it is going to be minus 5 by 3. So now if I wanted to make use of these values here, y I can calculate as 1 by 3 times of 5 minus 2 times of x1 value. Actually I have got a new approximation as minus 5 by 3. Minus, then minus 2x, and then minus z. Z actually I have not calculated yet. I can still make use of this value as 1. So this value, I got the value of y1. Got it? So next one actually, so here z1 value I can calculate with the help of this equation, 7 minus 3 times of the x value whatever I have got here. This is minus 5 by 3, and minus 4 times of the y value whatever I have got here, this y1. So this way I have got the value of z1. Now here if you notice, I started with an initial approximation, and then I calculated the subsequent steps as the initial approximated value I have made use, and then actually I tried calculating the updated values. These updated values I will make use in the next iteration. So I have got x1, y1 and z1, and if I wanted to calculate a better approximation to x1, x2, then I will make use of this y1 and z1 values to calculate x2. Got it? For the same equation. So x2 is going to be 1 by 3 times of 4 times of minus 2 times of y1 minus 7 times of z1. And similarly, y2 equal to 1 by 3 times of 5 times minus 2 times of x1, or x1 I have already calculated x2, and minus 7 times of z1. Similarly, z2 I can calculate as 7 minus 3 times of x2 minus 4 times of y2. So this way actually I can calculate the value of z2. Now this way actually I will keep on calculate the values till I get a value which is subsequently repeating the same values for the x, y, z values. So if it keep on repeating the same values more or less, then you arrived at that particular solution. So this is another method which we call as the Gauss-Seidel method or the iterative method. Gauss-Seidel iterative method. So this method is Gauss-Seidel iterative method. Got it? So this way actually you will be able to calculate again, you will be able to arrive at the same numbers, but with the repetitive method like this. But here the problem is, when we are trying to adopt this particular approach, so most of the times actually we don't know the problem is going to be converge or it is going to diverge. So this is one problem. And also even if it converges, right, it takes a lot of number of iterations to converge. So maybe actually if I notice actually when I was in BTech, right, so I tried writing a program for this, it was converged somewhere around 40-50 iterations. So that way actually it will be very tough to calculate. Sometimes actually it may go for non-convergent case also, but especially in UPSC, right, so they are going to give the case where it is going to converge within a steps of maybe 10 or maximum 12 steps, right? So this way actually you can keep on calculate iteratively, so that the accuracy of the subsequent steps, actually if you notice, if you keep on repeating the same number after 3 digits or after decimal, if there are 3 digits actually which are keep on repeating again and again, then you can stop from there. Got it? So this method is called the Gauss-Seidel method or the iterative method. Got it? So this is how actually we will be calculating the unknown solutions for, with the help of say, unknown set of simultaneous equations with the help of Gauss elimination, Gauss-Jordan, and the iterative method or the Gauss-Seidel method. Got it? So any questions on this? So the same thing actually you can calculate and then actually you can cross check it. You are going to get the same answers again, but it will take more number of iterations. That you have to be cautious. Clear? Any questions on this? Got it? So if there are no other questions, so I am going to stop the class for today. Yeah. Yes, exactly. So all these methods are valid only for the unique solutions. So these methods are not valid even if you have infinite solutions or if you don't have a solution also. That actually you have to be separately assuring that the rank method. So in linear algebra, right, you will be calculating the rank of the matrix, where if the rank of the matrix matches with the argument matrix, then you are going to get the unique solution. And other cases actually are discussed as clearly in case of linear algebra. But assume that these methods are valid only for the unique solutions. Clear? Yeah, that's all for today. Yeah.